we need to list all the orbitals for which n equals 4, and then tell how many orbitals there are in total. In the first case, when we have n equal to 4, we know in the fourth energy level, this is the energy level, we can actually have an S, P, D, and F sublevels, right? These are your sublevels, L. And this really represents L equals 0, L equals 1, L equals 2, and L equals 3. For the fourth energy level, those are allowable numbers for L, and we call them SPDF. Now, we need to actually get how many orbitals there are, or which orbitals are allowed. So when we look at this, we have one 4s orbital, because the s's only have one orbital in them. The p's, though, we end up having 3. We have 3 4p orbitals. Remember, the orbitals are about orientation. Now, for the d's, we have 5 4d orbitals. And finally, for the f's, we have 7 of the 4f orbitals. So, to answer this question, list all the orbitals for which n equals 4. They're basically right here. So that would be part A. So we went from energy level, n equals 4, to talking about sublevels, which are the L values, and finally to the orbitals themselves. Now, the next thing is going to be for part B. How many orbitals are there in total? Well, we only have one 4s orbital, plus we have the 3 4p orbitals, plus the 5 4d orbitals, plus the 7 4f orbitals. And when I add those up, I get a total of 16 orbitals, which is not a surprise, because if I asked you how many electrons there could possibly be in the fourth energy level, the answer would be 32 electrons, because it's 2 to the n squared. Remember, it's 2 to the n squared for the number of electrons. So 4 squared is 16 times 2 would make 32. So it is not a surprise to actually get 16 orbitals at this point.